Well, the first video in our course assignments playlist addresses the introduction to the ABC music notation and a short specification for this assignment, which consists of an ABC player. The expected learning outcomes from this presentation are that you shall be able to relate musical notes with pitch and frequency, and you shall be able to explain the ABC music notation and the functional features of the proposed ABC player. I do recommend you to visit this Wikipedia page on musical notes and pitch, where you will find more than sufficient information to introduce you to the basic concepts that will be useful during the course of this assignment. Actually, two musical notes with frequencies that are either half or double or 4 times their respective frequencies are perceived as very similar musical notes, so they can be grouped together in what is called the same pitch class, which are normally represented using the first 7 letters of the alphabet. Actually, the 8th note, which would correspond to the same name as the first, will have double its frequency, so again it will be perceived in the same manner as the first in this group. This graph on top right shows how the musical notes in the 4th octave going up to the 5th octave relate to the frequency of the corresponding sounds, and is extracted from this page. So another page that you should also visit is the one indicated here, which speaks about the piano key frequencies. A piano normally comprises 88 keys, covering 7 octaves. In the case of our assignment, we will consider only octaves 4 and 5, where the corresponding keys generate the musical notes with the frequencies that are illustrated in this table. This table was extracted from the Wikipedia page indicated here, but it is also obtained from the application of this formula, which relates the position of each key in the piano keyboard to its frequency. You shall notice that this column here presents the musical note using this notation that I have just included here, and which is the most common in the English language. The first column also shows you the representation of the same note using the Latin notation, the Latin names that are also frequent, such as do corresponds to C in the English notation. It corresponds also to C in the ABC notation. And so what this means is that we can actually represent any given note by using an ASCII character, meaning that any given tune may be represented by a simple sequence of ASCII characters that are stored in a text file. Well, the ABC music notation has been developed a number of years ago, and there are various applications that enable you to play the tune corresponding to any given ABC file. In the case of the ABC Explorer program, which is one of the most common, you can actually download it from this address. It will open the file and show you automatically the graphical representation of the musical notes, and it shows us that each ABC file comprises 2 main sections. One section which we might call the header section, and the other section corresponding to the representation of the musical notes. In this slide we are looking at the meaning of the headings that are comprised in the first section. We will not look into this in detail, actually because our ABC player will discard this information, so there's no point in spending time to explain what each of these parameters represents. Anyway, the ABC notation file or the ABC Explorer website provides ample information on the meaning of these parameters, as I have just said. Now, the part that is of most interest to us is the representation of musical notes and of their duration, which takes the form that is indicated here. In this case, this would be note A in the fourth octave, and M and P, which belong to the set 1, 2, or 4, represent the duration of the note. So, in this case, in this case here, for example, the duration of the note is represented in the form of 2/1. This means that it would be half a second times 2/1. That is to say, this note would have a duration of 1 second. Well, additionally, we will have to take into account that the start of the melody is indicated by this symbol, which also separates repeated sections, and the end of melody is represented by the symbol that closes square brackets. So the ABC player that we envisage to develop in this assignment may be represented as shown in this slide. It will enable us to use the PC keyboard to send a sequence of ASCII characters via RS-232 corresponding to the musical notes that we wish to play. So when we press the keys in the keyboard, it will work as a piano, sending over the serial communications channel the ASCII codes that will be read and interpreted as musical notes, and will be played in a loudspeaker that is driven by the Nexus 3 board. So the basic operating mode will be, as just said, it will consist of playing a tune on the PC keyboard. Now, a further operating mode may consist of playing and recording, in which case we will press the record button, then the recording LED will light, and from that moment on, whatever keys are pressed in the keyboard will correspond to musical notes that are played, and the corresponding ABC representations will be stored in the buffer inside the FPGA, and this will take place until we again press the record button, in which case the LED will turn off, and the ABC representation of the tune that has just been played, which was stored in the buffer inside the FPGA, will be uploaded back to the PC, where it can be played again using the ABC Explorer program. We will also want to be able to simply take an ABC tune file downloaded from the internet, download it to the Nexus 3 board, and press the play button, in which case that melody will play in the Nexus board. So the ABC player may be specified according to the functional features that are summarized in this slide. It shall support a range of 2 octaves, namely octaves 4 and 5, which are represented here in this table, going from a minimum frequency of 440 Hz up to maximum frequency of 783 Hz. And it shall play a tune directly from the keyboard. That is the minimum requirement, and I expect that every student will be able to achieve this objective. Then, in terms of further complexity, it shall be able to play an ABC file received via RS232C, which is an intermediate complexity objective. And finally, progressing to the upper level of complexity, it should be able to record the tune as it is played in the keyboard and to upload it back to the PC, as we have described in the previous slide. Well, you may assume that any given note will play until another key is pressed, and this applies for the play a tune mode, for example. That is to say, when you press a key, the corresponding note will start to play, and it will continue to play even after you release the key. Actually, it will continue to play until you press another key. If this new key is another musical note, it will change to the new musical note, otherwise the melody will just stop. So you can just play a tune using the keyboard and use the space key, for example, to stop the tune. This will actually simplify the implementation, since you don't have to worry about the duration of each musical note. Now, in what concerns the recording operating mode, there you might need to specify a duration when you upload it back to the PC. So what I suggest is that you consider m equal to b equal to 1 and build the ABC music representation in the FPGA memory buffer using this assumption. That is to say, every note will last for half a second. Well, finally, I would like to leave you with this question. You will have two main alternatives to implement this system. The FSMD-based solution, which consists of dedicated hardware, is the one that we are interested to focus on. But it would also be possible to develop a processor-based solution whereby the functionality would be developed in software. Well, we will concentrate on the FSMD-based solution, but once you progress with your work, I hope that you will be able to acquire the awareness to how these two solutions will compare in terms of, for example, speed, resources required, power consumption, etc. So anyway, you shall concentrate for now on the FSMD-based solution, and we may, time allowing, we may concentrate on a processor-based solution later on as well.